Very good morning, all of you. My name is Dhananjay Singh, and I'm a professor in the Department of Electronics Engineering at University of Foreign Studies, Seoul. Today, I'm going to talk about Internet of Things for Smart Community Services. So in these topics, we will talk more detail about the IoT technologies and the use of several applications. So in this talk, I'm going to highlight major three applications. So based on that, you all can understand about how the technologies work on that. So in this technology, we would like to first highlight what is the IoT. That is the very hot topic as nowadays, the most of the researchers and scientists are working on that. So the IoT is a convergence of sensing and communicating technology. So sensing and communicating technology means they are going to solve the real world problem for the development of smart community services. So in these services, we would like to use the system. That system would like to instantaneously identify any kind of object, such as the C++ is the extension of C language, and also object-oriented things. We are going to talk on that. So the technology uses, so we can reduce the waste of time and data pollution. So however, there are many challenges still existing in these topics, such as the internet connectivity, scalability issues, identification of the small tiny devices, addressing of the billions of devices. So these are the major challenges which many scientists and researchers are facing and still trying to make it realistic for their respective domains. So if you see this diagram where we have highlighted there, the one of the IoT applications we called the connected vehicles. So you can see there are the sensing device is associated with the vehicles, and then after local processing unit that we call gateway has a processing unit. And so what they do that, if there are the dashboard camera are sensing any kinds of obstacles, or then the sensing processing unit, they will sense like a dashboard camera. Also they are getting some obstacles, or the suddenly lane change, this kind of information. If processing units are checking, so they can react at the same time based on their alarm system, based on their suddenly brake, suddenly alerting system. The sensing processing unit means local processing unit can process it. But if the accident or there are the major computing power involved, so based on sensing processing unit's decision, the data will transfer to the cloud server. So when data should be transferred to the cloud server, there would be the internet connectivity. So we have to think what kind of communication protocols we are going to use here. 5G technologies, LoRa technologies, or related communication radar, and those kind of the vehicular communication network technologies we are going to use on that. So we will focus or boost on that based on cyber security challenges as well. So we must have to focus on these major topics to provide one internet of things services, one kind of application. Same architecture, we assume that the patient's monitoring case, healthcare applications. So the vehicle become as a patient's body, and then there are the sensing biomedical sensor devices will sense health conditions from the patients and then transfer to the gateway, and there would be again local processing unit and then involved to the cloud server. And then cloud server has the lots of statistics based on the disease, based on the patient's health condition, and then doctor can make action on that. So there are the two types of the processing units which we are considering for local processing unit and over the cloud processing unit. Okay, so these are the major what is the IoT technologies under that. So these kind of things are mainly involved on that. So another one is what kind of community services we can use it on that. So you can see here the IoT technologies can be achieved several ways. For example, controlling the things, as well as connecting for the monitoring, remotely monitoring of the obstacles. So this kind of technology, sensing and monitoring, are very much useful for the environmental monitoring, very much useful for the eco-friendly electronics devices, nanotechnologies, as well as smart community services. Smart community services, when we talk about that, the Community means the peoples are smart with the help of technologies. So everybody's nowadays are using smartphone. So that's why the terms come up, the smart community services. So the persons with the help of a smartphone, he can access the information remotely, as well as he can monitor the information remotely. The terms, it comes from the smart community services. The person or the peoples are associated with the technology. Okay, this is the main term. Otherwise, lots of people think about what is the smart community services means. That means the services they can get it from the technology. So here major getting information is the smartphone. Okay, so this is the one parameters. There are several research communities have proposed service oriented architecture. Okay, so service oriented architecture is one topic. Also, with the help of that, we can establish the communication, like sensing communication device for data management. A lots of sensing devices are producing data, how to manage those data. So it means there are the big data topics will come up, but they have to take the action as well at the same time. So it doesn't have to be wait for the data analysis. So based on those action, they can react. The technology can react or communicate to the relative persons on that. So we must have to think about the security and privacy challenges in this aspect, and various of the IoT applications as well. So there are the so many things are involved. So in this talk, mainly I'm going to talk about these three major applications. One is the global healthcare monitoring system that we call e-healthcare system. Then we talk about the intelligent transportation system, means ITS technologies. Then we talk about the safe and smart driving solutions that is also associated with the IoT, ITC technology. So information communication technologies are involved to establish the communication for healthcare industries or for transportation industries or environmental industries, several other industries as well. So today I'm mainly going to highlight these three challenges which we are going to solve the problems. So before going to establish the communication, I would like to talk about the, because IoT device is very tiny device, how we can connect the internet technology over there. So one of my research topic was 6LoWPAN device. So where we used IPv6 low power wireless personal area network. So in this technology comes for the ITF working group that we call the Internet Engineering Task Force. So they are the responsible to establish the communication medium from tiny device to the till now the IPv6 and IPv4 internet technologies as well. So we can talk about the tiny IoT devices that we call low power. Okay, so low power radio frequency plus combined with the IPv6 network. So that we called 6LoWPAN. Okay, so that also come up the name of the IPWSN, because the LoWPAN, it's called low power wireless personal area network, that is the ZigBee IEEE 8015.4 standard. So those standard we use very much for the healthcare applications for wireless sensor network. So we connect biomedical sensors there. And then once we connect the IoT technologies, that means we have to collect information like remotely. It means we need to connect internet over there. So when we talk about the internet, means IP protocol, like internet protocol. So that's why the name come up IPWSN. So wireless embedded in internet, also we call the 6LoWPAN tiny devices. That is the wireless embedded internet technology. Then there are the adaptation layer, that is the part of the, if you know the TCP/IP stacks. So data link layer is the part also, the adaptation layer, the MAC layer and LLC, between that we use for the adaptation layer. So that is responsible for routability of the packets from IPv6 domain, like one gateway, to the personal area network domain. So we have established some protocols to establish the global communication for small tiny devices. So the major benefits for the 6LoWPAN devices, it is the open, long-lived, reliable standard, and then also transparent internet integrations, network maintainability, and global scalability into in data flow. So these are the major benefits for the ITF working group that called 6LoWPAN devices. If you see this diagram, the picture is showing that the left side diagram is showing that TCP IP stacks. Here you can see here TCP IP protocols stacks, and between that the gateway protocols stack, and then end of that this is the 6LoWPAN stacks here. So what we do that we can see here there is the adaptation layer that we call data link layer. So there is the adaptation layer has IEEE 8015.4 MAC layer, and over there is the adaptation layer. Same thing, it goes to the 6LoWPAN side as well. So both are communicating to establish the network from personal area network with the global area network that we call the IPv6 based protocol stack as well. So to work these kind of topics, initially there are lots of the standard companies and standard bodies. They were initially try to solve the solutions based on 6LoWPAN technology. So 6LoWPAN is also the IPSO Alliance, which are promoting IP means internet protocols, or we can say IPv6 for smart object. So they were trying to connect this is the one alliance. Then ArchRock, they made their only 6LoWPAN devices. iBit is the Korean company. They have also made the 6LoWPAN devices. So mainly those SensiNode, they are the, as I know that they are the first developer for 6LoWPAN devices. So I have tested these devices in real time. So let me show you some of our work. So there are, as I just mentioned, that the ITF working group, the Internet Engineering Task Force, they are the responsible to provide internet connectivity over smart tiny devices. So I have contributed the ITF working group to development of the IPv6 header compression for the 6LoWPAN connectivity. So here, that time they have RFC, the 6280. So the current RFC has recommended the data compression schemes and does not offers destination IPv6 address compression during the global connectivity, and in node mobility scenario has 8-byte prefix node and then put the inline of the compressed packet. But our proposed algorithm is showing that the adaptation identifier, if you see over the gateway, we have used the AID protocols. So adaptation identifier protocols would be as a translation table. Okay, so they are translating the IPs between the in nodes and the outer nodes. That is the main parameter. So in nodes like 8015.4, they have lots of sensor devices. So they are making the individual IDs for each nodes. Okay, so the data gateway will be responsible to provide the one unique ID for the in nodes and then out nodes that we call IPv6 network. So once we use for this one, so at that time we say that less than 1 bytes we have used between the gateway and in nodes compression, which one is saying that before was 16 bytes, and when we use this technology, so we use this concept, so we use less than 1 bytes for the destination IP address. So based on this kind of comparison table, we have tested in our laboratory. These are the SensiNodes devices. So we bring it and then we tested this algorithm in the real time domain. So this is very good solution also to provide the global connectivity for the small tiny devices that we call IoT devices. Another one we call the sensing communication devices. Once the sensor nodes are connected, so they are producing large heterogeneous data, heterogeneous devices, then the complexity is getting more and more. Okay, so there are another scenario, there are the client and server between the communication things, right? So previously there was the two clients, like smartphone, we can access the server and then data can communicate between that. But now once we connected to the IoT devices, okay, that we call ID based or IP based object networking, so where the sensing stuff's converted as well. So the peoples can, the clients can take real-time decision for the, in this scenario. So that's kind of things we call Internet of Things as well. So in that case, there are the large number of the data. So the problems come up here when we have billions of devices and millions of the data devices are producing the data. The machines, they both can communicate. One device is communicating another device is communicating another device. Then how they can understand the information between two machines. That's the point the big data topics come up. But once we go to the big data analysis, then we have to lie over the cloud server. But as I mentioned before the slides, we have to take instantaneously a decision. At that point, we have to create small middleware systems as well. So where the one machine is sending data to the middleware, and middleware taking at once decision, converted to the information to another machine. And other machines are also sending their data to the middleware, and middleware converted to the information to another machine. So once machines are getting information, they can take the action. Okay, so data is the raw data, but when we talk about the information, it means the information. Okay, so those information is they have to take the action based on those information. So these are the major communication and sensing technologies. Now I'm going to talk about the community services. So one services I just mentioned before, we are going to talk about the healthcare that we call e-healthcare services. So in the healthcare services, there are the overview processing system architecture. If you see this diagram, so the diagram is showing we have healthcare. Here you can see there the low pan devices are connected over the patient's body, like ECG, PPG, blood pressure, and EGG data to collect from the patient's body. And then after those data transferred to the edge cloud computing, that we call that the information centric networking can also provide the only healthcare related data. They can establish the communication. So between the patients scenario, like the patients are lying on the bed in the hospital. Okay, we assume that in the hospital has several patients, and those data can use multi-hop communication transfer to the edge cloud computing gateway, and then gateway will transfer to the control center where they can control and checking the information, and then it goes to the coordinator. Then they can make to the action, like they can the coordinator could be the doctor here in the case of this. So doctor can make an action and then give the information to the patients as well. So which medicine he has to take at the point, and what kind of information he can collect it from there. So in this is the one healthcare processing scenario. So in this scenario, we have also worked for the mobility scenario and the connectivity scenario. So you can see this is the healthcare area. We have assumed that, and the sensors are connected over the patient's body, and patients are moving within the hospital with the different departments. As like once patients are staying in the hospital, so they have to go for the checkup in blood pressure, pressure departments, MRI departments. They have lots of the camera departments that we call the CT scan departments. So once they are moving, and that time also they are collecting information to the cloud server. So these are the real-time data communication. So we have made this kind of statistics analysis. So these are the 6-LoWPAN IDs. If you see there, so what we did that each patients are consuming one 6-LoWPAN devices, and which is combining of the several biomedical sensors. So those biomedical sensors are collecting data like ECG, PPG, temperature data to the cloud server, or we can say for the doctor's applications as well. So they are the level 1, level 2, level 3. So you can see level 0 is connected with the PAN coordinator, or we can say that the gateway. So they are all patients' data are associating in this gateway. And then this is the smart hospital area. If you see, there is the smart hospital area, and we use for the personal area network. So the combination of the all biomedical sensors, and then red one is showing that the patient is moving from one place to another place. Then how they can communicate, what kind of algorithm is going to perform on that. So these are the major challenges which we have tackled. These are the communication medium. This is the combination of the biomedical sensors data. These are the 6-LoWPAN addressing. These are the stacks. And then this is the mobility protocol, the one area to another area when patients move, then what kind of system will combine. This is the algorithm, how it process it. And then after, this is the major processing monitoring model. So this is the made by our laboratory. When I was doing my PhD at the DSU, so at that time, one of the students has made, Sangjun has made these biomedical devices, and then we prepare the communication protocols for the communicating the device to the doctors as well. So at that time was PDA. No, there was no smartphone. I'm talking about 2006, 2009 and 10. At that time, we have tested also those algorithms. This is the we call Contiki. There is the one protocol. So or pink colors note, there is the arrow is associated. These are the mobility. So the patients, we assume that these are the patients that they are moving from one place to another place. And yellow one is showing the statistics node, static nodes. So they are just putting the, so the static nodes working as a multi-hops communication. So blue one is the gateway. They are collecting all patients' information. So we have tested this kind of algorithm first. Then this is the real-time scenario. So blue one is the patients, they are moving, and then red one is the gateway. So there are multi-hop communication. These all are the IPv6, or we can say 6-LoWPAN devices IP addresses, and these are the parameters data information. So we tested one simulator is here, another one is this one, another one is this is the iBits company. We tested here iBit, they have provided gateway, and these are the sensor nodes. So the generally those protocols provide humidity, temperature, and flux, those kind of xylo sensors data. So we tested this kind of information in the laboratory, and this is the IPv6 addresses. And IPv6 address means showing the connectivity of the each nodes between the gateway. And this is the real-time ECG data monitoring application. So we use for that one applications. So this one was the one healthcare applications, which we talk about that. It was, this work was very long back when I was doing my PhD thesis at Dongso University. That time it was the work on that. And now we are going to talk about the intelligent transportation system. So ITS system is also very much important. This system is useful for the recent research topics. There are lots of people who are working for the autonomous vehicle and the driverless car. At that time, we started working in this topic in 2015. At that time, we thought about that since 1886, when the first car has appeared in the world, the almost all data have got lost. Means there are no system involved which collect the vehicles real-time driving's data. So means every company is take care about their individual vehicles data information. But as we know that the internet got so much popular last 10 to 20 years, very much used for the applications purpose. Then people start thinking about the collecting data as well. But so far, there are not any company who are collecting all real-time driving feedback, driving data information. So we know that when we want to buy any car, so we can see the statistics. That is statistics provided by the individual companies, and based on that we can make a prediction or can decide which car is the good one, which car is the bad one. But real-time scenario we cannot see in our real-time driving feedback, or from the drivers we cannot get any kind of information. So we thought about that. So since 1986 to till now, no data storage, and there exists no open access car related data and information beyond the navigation system information. Only navigation informations are available, but not the accelerometer data, like I am driving, how much times I have pressed the brake, how much roughly I am the driver, what kind of things. So if we know these all parameters, so we can work more better and we can provide, get more benefited on that. So we thought about that, the vehicular cloud system. So vehicular cloud system can provide an open platform to share car related data in the internet. So when we think about the car related data in the internet, so we are going to collect all drivers data as well in somewhere in the cloud. That is our main goal for to develop in this kind of topic. So in the ITS system, intelligent transportation system can reduce the amount of pollution as well as provide early traffic message that can create during the movement of the vehicle on the road. So if you know that which street has lots of traffic, where has lots of conjunctions going on, so the driver can change their lane, those kind of information. The Google is already providing nowadays, but we wanted to collect each driver's pattern data as well. So there are the cloud server that we call vehicular cloud system. So in the vehicular cloud system, we provide about the security algorithms, and there are so many protocols. They can collect real-time vehicle data from the street to the cloud server as well. Okay, so in this system, when we are going for that, so when we are collecting the vehicle data from drivers feedback, if some accidents happen on the street, so the people's like police station, hospital people, their family members get at once the information and they can make the action on that. They can so we can save a lot of life in this kind of scenario. As you know that a lots of deaths caused because of the not at the time of the care of the driver accidents place. So if some major accident happen, so the peoples can take at once action, so maybe we can save a lots of life. So this is the main purpose of the topic. So in the current scenario, like here, one accident happened, the series of the vehicles got accidented as well. So especially this is the rainy season and fog area and the snow times, this kind of accidents we used to see that. So in that kind of system, like we called one collisions happen, so multiple or series of these collisions happen. But once we use this kind of technology, if this is happen, the data will go to the cloud server and cloud will be at once distribute the communicate with 100-meter range of the place. So other vehicles can take action. So they can prevent the major accidents as well. So this is one solution. We thought about that, as well as if the accident happens, so those data goes to the cloud server and cloud server will make the decision based on the accident. So their family members and police station and hospital people get to know that in this spot has accident and now they have to fix the they have to take the action based on the accident, the density of the accident as well, how major that accident it is. The hospital will be ready to that, and other vehicles within that range, they can open also their camera and they are taking the real-time picture over the accident spots and uploading over the cloud server. So once they everybody is associated with that scenario, so the insurance company, policeman, hospitals, family member, they are getting at once those kind of data. So that could be the also very good solutions for the IoT applications. Once the technology is connected with the vehicle and vehicles are going to communicate with the persons and the related respective society or respective technologies as well. So this we are working in this topic. So this is also one good solution, but still now there are no standard protocols available for this kind of technology. So there is the IEEE standard standards for connected vehicles. So we can see there are the IEEE, they are providing so many standards for establish the communication technology. So this diagram I got from the APEC vehicle symposium. So I like this one, so that's why I have included. So who has interest on that, so they can go to this IEEE 8015, this kind of all standards, and study about this and do research, and they can decide what topics could be the good for their future research aspects as well. So this will be another applications could be very good for them. And another topics we would like to discuss today, where is the safe and smart driving solutions. So safe and smart driving solutions is also one applications where Internet of Technology involved. So what we do that in this system, we are collecting the internet technology over the vehicle, like and dashboard camera. So once we are connecting the internet technology with the vehicles, and then there are the lots of people can get benefited. First of all, the customer who is using the vehicle, he can get real-time feedback driving scenario. He can reduce the cost efficiency analysis, car health remotely monitor system as well. If something is going to on, so they can communicate to their mechanic as well. Right, this kind of system we want to get benefited once we connected to the internet over the vehicle as well. As well as the business aspects, if we think about that, the insurance company get to know the health condition of the vehicle, so they can give the discount to the persons in future. Driving feature feedback from the drivers, they can also provide the discount. Car sharing technology, logistics, and one of the best business is the second-hand car market. So everybody, once they buy second-hand vehicle, so they know that what is the health condition of the vehicle, so they can fix the price on that. Like today, if somebody want to sell their car, 5 years after 5 years old car, they want to sell to the market, and another person who is very rough driver, and after 5 years he is also selling his car. So the people cannot see because they don't have real-time data who is the good driver and bad driver, even though they can bluff to the new customer, and they can sell the same cost price of the both vehicle based on the external architecture and face on the safe of the vehicle. But if we have real-time driving feedback data, for example, I'm the bad driver, another guy is the good driver, and after 5 years we both want to sell our vehicles. So bad driver statistics, engine statistics, driving features will tell he has used very roughly his vehicles, another guy used very carefully his car. So the cost will be the big difference between my selling after 5 years and another guy selling my after 5 years. So these are the parameters we wanted to provide the solutions. So how we get it on into that? So since 1996, every car has OBD ports that we call OBD2 ports. So you can see there is the vehicle, and here is the dashboard. This circle one, dotted circle is showing that OBD port. So every vehicle has this port nowadays. So if we have some problem, we go to the mechanic, and mechanic use his OBD device and then connect it, and then tell us, okay, you have 2 sensors are failed, we have to replace that, this kind of things going on. So that we made this device, 10 devices, the device will fix over that, and then collecting real-time data from the all sensors. And once they are collecting real-time data, so those data transfer to this smartphone. Actually, we made this kind of devices. Let me show you, because I am associated with the one startup company. So we make this this device. So in this device called OBD scanner port, that is the 2. So this device will connect any car, and we can download mobile apps. So mobile apps can collect all sensors data in the smartphone, and based on our algorithm and services, they can make the action. So I'm going to talk about that a bit about that. So what we do that we use for the dashboard camera and OBD ports, these OBD scanners over the vehicle. And you can see this is the spot where we can connect it, and the data goes to the cloud server. So once data goes to the cloud server, that we call OBD scanner port, and with the help of a smartphone, because to save the cost, almost every driver is using nowadays smartphone. So the Bluetooth enable a mobile phone, and the device has Bluetooth communication, and then establish the communication between them. So easily data can collect to the smartphone as well. And when data goes to the smartphone, it uploaded over the our defined cloud server. Okay, so the data goes to cloud server, then taking the action over the computing power over the cloud server, then can produce the certificates and getting the information. After the data management web services that we call big data analysis cloud server as well. So this is the mini dashboard, mini camera, as well as OBD scanner ports. Both of them are associated with the smartphone, and then those data goes to the cloud server, and then it will make the action based on the smart data as well. So let me show you the, for example, insurance company, car sharing market, taxi company, they get to benefit it, as I mentioned before, once they are collecting data from the driver's feedback behavior. So these are the our algorithm. For example, the OBD scanner are collecting the real-time driving coaching with the respect of the position and throttles. So for example, the driver is pressing lots of engine, means they are driving rash, and brake, pressing lots of brake during his driving pattern. So those information, and there are once they are driving rash, so there are the engine noise as well. So those all the engine sound equalizer for better understanding, throttle position for the fun. So those all data we are collecting, and this is the our mobile apps. So based on those how much miles he has driven, how many times he has pressed the brake, how much times he changed, suddenly lane change, those kind of all speed is exceeded over the limit, given the limit. So those all parameters, then we combine this algorithm that we call the OBD data. So here we generate our own formula, and then based on those formula, we generate these are the parameters that collected from the sensors from the vehicle, real-time vehicle as well. And then we find out the one application we call sweet spot analysis. Sweet spot analysis means we are using linear acceleration, mass, airflow, we are using the drag efficiency and cognitions, rolling resistance, and pitch analysis. So these all are the data, and then we can find out this formula we generated, and then we find out the sweet spot. So this is the real time and throttle sweet spots analysis for the road load power algorithm. So we design one algorithm. So based on this algorithm can find out the sweet spots as well, and also to contribute to reducing the waste of car fuels as well. So we can reduce this kind of driving behaviors to fuel efficiency, and we can save the energy as well. This kind of algorithm also will help to the physical limits of the car engine performance. So how much long the engine will be performed in this kind of algorithm and scenario, we can use it on that. So you can see this application where we have tested on that. For example, the one guy who is driving very nicely, and then after he's going from his home to his office, and when he's driving, so based on those algorithm and parameters, we find out from 0 to the in the one, then we can see the statistics of this driving behavior. Another guy, this one red one is showing that the wasting energy, the guy who's very rash driving and changing suddenly lane, pressing lots of brake, so he's wasting lots of energy and giving a lots of pressure to the engine as well. So based on his quality of the driving, another guy's quality of the driving, we can predict the driving patterns as well. So once we do that, so the technology can see that we can in the hard brake and speed exaggerates, we can generate the point-based system as well as some statistics. So OBD scanner can get to know that how much the real-time systems he is doing. So the system can tell them, please do not press hard brake, do not change lane. With the real-time driving coaching from the sensors, we can also, our algorithm can generate them as a voice or the text, how we want to do that. So they can get the real-time coaching feedback as well as the systems can save lots of driving pattern. For example, do not hard brake, hard acceleration, speed exceeding, suddenly lane change. This kind of pattern the sensors will tell us during the driving times at the drivers as well. So this is the safe driving. And smart driving means if somebody is following the whole rule, so it can reduce the fuel cost and right time supply replacement. Something is going to be break, and then they can replace at the time because they know the life of the things and products which are used inside the vehicle. Fast path finding, easily we can go for that. So based on this, we can save engine quality, we can increase as well. The life expectancies of the vehicle we can increase as well. So once the persons can drive and come back at home, so this kind of solution is also very good for the teenage driver. So they can drive it, and then once they after come back home, the parents and family member can analyze it. What is the performance and how much good he has driven today, and what is the performance of his driving scenario based on that as well. So we can see this kind of the trip history, diagnosis of the engine, how much he has pressed the. So this kind of certificate can generate it. For example, monthly wise, yearly wise, and then insurance company get the benefited from this kind of driving behavior. And after 5 years